Behind every powerful AI model, there is a hidden hero, that is data pipeline. Think of it as a factory assembly line where raw messy data is collected, cleaned, and labeled before it finally powers intelligent machines. First, we collect data from apps, sensors, images, videos, and endless stream of online activity. Without collection, there is no AI. Next, we clean the data. Why? Because raw data is messy. Missing values, duplicates, errors. If we don't fix them, the AI will fail. Clean data is the secret sauce of accurate predictions. Finally, we label the data. A photo tagged as a cat or dog, or an X-ray labeled healthy or disease. These labels are the teacher that trains AI to understand the world. So remember, great AI does not start with fancy algorithms. It starts with a strong data pipeline. Because in AI, garbage in means garbage out. Stay tuned because in the next slide, we will break down each step with a real world examples from self-driving cars to healthcare and e-commerce. Why data pipelines matter so much in AI? Because without them, even the smartest algorithms are useless. A data pipeline is like a factory assembly line. Raw messy data goes in, and step by step it is refined into high quality fuel for AI. First, it ensures data quality, accuracy, consistency, and reliability. No more messy, broken data ruining your models. Second, it provides scalability. Imagine handling millions of records at lightning speed. That is the power of pipeline. Third, it maintains traceability. Every step leaves an audit trail, so compliance, debugging, and accountability become easy. And finally, it supports reproducibility. You can retrain your models anytime with same inputs and get the same trusted results. That's why data pipelines are the hidden backbone of AI success. Without them, it is garbage in, garbage out. The very first step in building AI data is data collection, because without data, there is no intelligence. AI applications thrive on three kinds of data: structured data like databases, spreadsheets, and purchase logs; unstructured data like text, images, audio, and videos from social media or medical scans; and streaming data, real-time feeds from sensors, stock markets, or even your smart home devices. But here is the secret. Collecting data is not about hoarding everything. It is about collecting what is truly relevant. What are best practices? Use APIs and web scraping for automation, IoT devices for real-time analytics, and crowdsourcing platforms for labeled datasets. About biggest challenge: ensuring privacy, following rules like GDPR and HIPAA, and avoiding biased sampling, because biased data means biased AI. So, great AI begins with smart data collection, the right data from the right sources with the right ethics. Raw data is messy, and if you don't clean it, AI will fail. Think about it: missing values in surveys, inconsistent formats like US, USA, United States, sensor glitches creating errors, duplicate entries for same customer, or even extreme outliers like $1 million transaction in retail log. That's why data cleaning is so critical. It transforms chaos into clarity. We fix missing data with imputation, standardize formats and units, remove duplicates, detect outliers using statistics, and normalize everything so models can learn rightly. Here is the catch. Data cleaning is not glamorous, but it takes up nearly 60 to 80% of data scientist time. And yet, it is the backbone of trustworthy AI. Without it, even the most advanced models collapse. So remember, in AI, the magic don't start with algorithms. It starts with clean, reliable data. AI doesn't just learn from data, it learns from labeled data. Labels are the teacher that guide AI to make sense of the world. Think about it: a photo tagged as cat or dog, a sentence marked as positive or negative, or an X-ray labeled abnormal or normal. Without these labels, AI is just guessing in the dark. There are three ways we label data. First, manual annotation. Human experts or crowdsourced workers tagging examples. Semi-automated labeling, where machine pre-label and humans verify. And third, programmatic labeling using rules, heuristic, or weak supervision tools like Snarkel. But here is the catch. Labeling is hard, it is expensive, time consuming, and can even introduce biases if annotators make mistakes or bring cultural assumptions into the task. That's why the best practice is clear guidelines, multiple annotators per cross-checking, and continuous validation against real-world results. Remember this: the accuracy of your AI is only as strong as quality of your labels. Garbage level mean garbage intelligence. Now let us put all together. The data pipeline is not a straight line, it is a cycle of continuous improvement. It starts with collection, gathering data from structure sources like databases, unstructured sources like images or text, and even real-time streams from sensors. Next comes to cleaning, fixing errors, removing duplicates, and standardizing everything so the data is reliable. Then we move to labeling, adding meaning through annotations, the step that teaches AI what data really represents. Finally, we get the output, a high quality dataset, polished and ready to train powerful AI models. But here is the key: this process loops back. Every time errors or gaps are found, the pipeline feedbacks into collection or cleaning. That is how AI gets smarter, stronger, and more accurate over time. So, how does a data pipeline work in real world? Let us look at three powerful examples. First, self-driving cars. Cameras and LiDAR collect endless streams of images. The raw data is cleaned to remove sensor noise and then label pedestrians, lanes, traffic signs. Without this pipeline, autonomous cars could even stay on the road. Second, healthcare diagnostics. MRI scans are collected, noisy scans are removed, and radiologists label conditions like normal or abnormal. This pipeline turns images into life-saving insights. And third, e-commerce recommendation systems. Every click, every purchase, every scroll is collected. Duplicate or bot clicks are cleaned out and data is labeled as browsing versus buying. That is how AI learns what you are likely to buy next. From cars to hospitals to online shopping, the data pipeline is the invisible engine making AI practical, powerful, and real. AI has two big moments in its life: training and inference. Think of training like going to school. The AI is learning from tons of examples, making mistakes, and improving. Inference is AI uses what it learned to give you real answers in the real world. Training builds the knowledge, inference applies it. Together, they make AI powerful, smart, and useful for everything we do today. Training is how an AI learns to think. The model looks at millions of examples, finds patterns, and corrects itself again and again until it gets smarter. Think of it like a student practicing problems. Make a guess, check the answer, fix mistakes, and repeat this cycle millions of times. But training needs use power, advanced GPUs or TPUs, and it can take hours, days, or even weeks. This hard work is what gives AI the knowledge it uses later in the real world. Training AI is not easy, it is heavy lifting. It needs huge amounts of data, often terabytes of examples. It costs thousands of dollars in storage, energy, and hardware, and it runs 24/7, sometimes for days or even weeks. For example, to teach AI the difference between cats and dogs, you don't just show a few pictures, you show it millions. This massive effort is what gives AI its superpower to recognize, predict, and perform. Inference is where AI comes alive in the real world. After all the hard training, this is the moment AI shows what it has learned. You give it new input like uploading a photo, and instantly it applies its knowledge to give you the answer. It is fast, accurate, and often in just milliseconds. For example, train an AI to recognize cats and dogs. The next time you upload a picture of cat, it immediately tells you this is a cat. That is inference, AI in action, right at your fingertips. Training and inference may sound similar, but they are totally different. Training is the heavy work. The AI learns pattern from massive datasets using powerful GPUs. It takes hours, days, or even weeks, and it costs a lot. Inference is the payoff. The AI applies what it learned to new data. It runs light, often on your phone or laptop, and gives results in just milliseconds. In short, training is the brain building phase. Inference is the action phase, which is fast, smart, and ready for real world use. Here is a real world example. You know well, voice assistants like Alexa, Siri, or Google Assistant. During training, the AI learns from thousands of hours of speech recordings. It listens to different accents, languages, background noises, and speech patterns, so it can understand human voice in all situations. Then comes inference, the part you use every day. You say, play music, and instantly the assistant understands your intent, process your voice in real time, and execute the command within seconds. That is the power of training and inference working together to make AI feel smart and natural in our daily lives. Fraud detection is one of the smartest uses of AI. In the training phase, the system learns from years of bank transactions, both safe and fraudulent, and builds patterns of suspicious behavior. Then in real life, when you swipe your card, the system instantly checks the transaction against those patterns, and within milliseconds it decides approve it or flag it as suspicious. That is AI in action, protecting your money every single day. Healthcare is where AI truly saves lives. In the training phase, AI studies millions of X-rays labeled by expert doctors. It learns to recognize even tiniest patterns that may point to diseases. Then comes to inference phase. A new X-ray is uploaded, and within seconds, the AI highlights possible issues. This helps doctors make faster and more accurate diagnosis, giving patients a better chance at early treatment and recovery. That is the life-saving power of AI in healthcare. Why does the difference between training and inference matter? For developers, it guides where to focus, improving training for better accuracy or speeding up inference for faster results. For business leaders, training is a big investment, but inference is where customers feel the real value and revenue is generated. And for AI products, success depends on balance, strong training to build accuracy and efficient inference to keep users happy and engaged. That's why this distinction is not just technical, it is critical for future of AI. Training builds the brain, inference uses the brain. Without training, AI can't learn. Without inference, AI is useless to people. Both pages are essential. Training creates the foundation of knowledge, while inference delivers real value in the real world. Think of it this way. Training is like studying hard to gain knowledge. Inference is applying that knowledge when it really matters. Together, they make AI smart, useful, and impactful. Artificial intelligence may sound complex, but it all begins with a few simple ideas. In this video, we'll uncover the key concepts that power every AI and machine learning system called features, labels, epochs, overfitting, and underfitting. Think of features as the clues, labels as the answer, epochs as the practice round, and overfitting and underfitting as the mistakes models make when they don't just land the right. By the end, you'll see how these building blocks connect raw data to real intelligence. So stay tuned because understanding these concepts is the first step to mastering AI. Let us start with most important building block of AI called features. Features are input variables, the signals that describe your data. Think of them as the ingredients in a recipe. Better ingredients make a better dish, and in AI, better features make a better model. For example, when predicting house prices, features can be the number of bedrooms, square footage, or location. In images, features are pixel values, colors, edges, or textures, things that help classify what is inside a picture. And here is the golden rule: choosing the right features often matters more than algorithm itself. This is why feature engineering is one of the most powerful skills in AI. Now that we know features are the inputs, let us talk about labels, the outputs. Labels are what we want the model to predict. If feature are the ingredients, labels are the final dish we are aiming to cook. For example, in spam detection, the label is either spam or not spam. In stock forecasting, the label is tomorrow's stock price. And in healthcare, the label could be disease or healthy. Simply put, features are what we know, labels are what we want to know, and together they form the question and answer field that makes AI smart. AI doesn't learn everything in one go, it learns through repetition. An epoch is one complete pass through the entire dataset, but one pass is never enough. That's why we train models over multiple epochs, allowing them to slowly adjust and discover patterns. For example, with 10,000 training samples or pi echoes, the model actually sees every sample 5 times, getting better with each round. But here is the catch. Too few epochs and the model doesn't learn enough. That is, underfitting. Too many epochs and it memorizes the data, that is overfitting. The secret to powerful AI is finding that sweet spot in between. Overfitting happens when an AI model learns too much. It doesn't just learn the real pattern, it also memorizes noise and random details from the training data. As a result, it performs great on practice data but fails when faced with new data. Think of it like a student who memorizes answers without understanding concepts. They score high on practice tests but fail in real exams. That is overfitting, knowing the answers by heart but not truly understanding the subject. How do we recognize overfitting? It shows up as very high accuracy on training data but poor accuracy on test or real world data. In short, the model has memorized instead of learned. So what causes it? Models that are too complex, training for too many epochs, or skipping regularization techniques. And here is how to fix it. Use regularization like L1, L2 or dropout. Add more diverse training data. Or stop training early when validation error starts rising. The goal is simple. Train a model that doesn't just ace the practice test but performs well in the real world. Underfitting happens when a model is too simple to capture the real patterns in the data. It's like a student who barely studies and give generic answers, failing both practice and real exams. The telltale sign of underfitting is low accuracy, not just on test data, but also on training data. In short, the model has not learned enough to make sense of the data. Underfitting happens when the model is too weak to capture the real patterns in the data. There are three big reasons why this happens. The model is too simple, for example, using linear regression on highly complex data. The model has not been trained enough. Too few epochs mean it didn't get enough practice. Or the features are poor, irrelevant, or missing inputs stop the model from learning properly. So, how do we solve it? Use a more complex model, train longer with more epochs, and most importantly, improve feature engineering by adding the right data with domain knowledge. That is how you turn an underperforming model into a smarter one. Now let us put everything together with a real world example predicting customer purchases. First, we look at the features, things we already know about a customer like age, income and browsing history. Next comes model training. The model goes through multiple epochs, learning patterns while avoiding the traps of overfitting and underfitting. Finally, we predict the label. Will the customer buy the product? Yes or no? And here is the golden rule. Balance is key. Train long enough to capture real patterns, but not so long that the model memorizes specific customers instead of general buying power. This balance is what makes AI predictions powerful and useful in the real world. To truly unlock your AI potential, you need to master the fundamentals. These five concepts, features, labels, epochs, overfitting and underfitting are the foundation of every AI system. They give you the knowledge to understand why models behave the way they do. They give you the language to speak about AI with confidence. And most importantly, they give you the power to build AI solutions that deliver real results. Remember, master the basics and you will be ready to shape the future of AI. Artificial intelligence is moving faster than ever, but behind the magic of smart AI models, there are powerful tools and frameworks that make everything possible. Think of them as the toolbox for AI engineers, helping us build, train, and deploy models quickly and efficiently. In this section, let us explore three of the most powerful ones. PyTorch, which is loved for its flexibility and research-friendly design. TensorFlow, which is known for large-scale deployments and production-ready solutions. And Hugging Face, which is for pre-trained models and natural language processing. These tools are what turn AI ideas into real-world applications, powering everything from chatbots to self-driving cars. So let us unlock the future of AI with PyTorch, TensorFlow, and Hugging Face. Let us talk about PyTorch, one of the most powerful deep learning frameworks today, which is built by Facebook AI Research Lab. What makes PyTorch special? It is known for its flexibility, simplicity, and Python-friendly design. What are the key features? It uses dynamic computation graphs, meaning you can build and debug models on the go. It has strong community support with tons of tutorials, pre-trained models, and contributions from developers worldwide. With TorchScript, you can take your research models and make them production ready, running smoothly on servers, mobile devices, or even embedded systems. And thanks to GPU acceleration, it delivers high performance training with CUDA integration. What are the use cases? PyTorch shining cutting edge research like NLP and computer vision, rapid prototyping of AI models, and even powering real world systems like recommendation engine and fraud detection. So think of PyTorch as the researcher choice, perfect for experimenting with new ideas while still strong enough for large scale deployment. Now let us talk about TensorFlow, one of the earliest and most powerful deep learning framework developed by Google Brain. TensorFlow is famous for its production grade scalability and a massive ecosystem of tools. What are the key features? It supports both static and dynamic graphs, giving flexibility and performance. With TensorFlow extended, you get a complete production pipeline for training, saving, and monitoring AI models. TensorFlow Lite brings AI to your phone and edge devices. TensorFlow.js lets you run AI models directly in your web browser. And with Google Cloud AI integration, deploying enterprise scale AI is seamless. What are the use cases? TensorFlow powers Google Search, YouTube recommendations, cloud native AI, and large scale deployment across web, mobile, and IoT. So think of TensorFlow as the enterprise powerhouse, perfect for companies that need scalable, production ready AI systems. Finally, let us look at Hugging Face, the platform that has truly transformed the AI world. Hugging Face is famous for making state-of-the-art AI model accessible to everyone. What started with transformation library has now grown into full AI ecosystems. What are the key features? The transform library gives you thousands of pre-trained models for text, images, audio, and more. The Model Hub is a massive community where developers share and reuse models. With datasets library, you can quickly test and train AI ideas. The inference API and spaces let you run model instantly in the cloud or even build AI apps without heavy coding. And it works seamlessly with PyTorch and TensorFlow. What are the use cases? Hugging Face powers chatbots, sentiment analysis, translation, summarization, and even generative AI like text to image or audio. Think of Hugging Face as the AI democratizer, putting powerful AI tools into hands of everyone, not just big tech companies. Now let us compare the three big names in AI framework: PyTorch, TensorFlow, and Hugging Face. PyTorch is easy to use, works with dynamic graphs, and is loved by researchers. It is best for research, prototyping, and flexible projects. TensorFlow is the enterprise powerhouse. It is scalable, production grade, and works great for large scale systems and enterprise AI solutions. Hugging Face is a community favorite with pre-trained models and easy access. It is perfect for NLP, generative AI, and rapid deployment. To sum it up, PyTorch shine in research and innovation. TensorFlow rules enterprise deployment, and Hugging Face makes AI accessible to everyone. So each tool has its strength, so the best choice depends on your AI journey. Here are key takeaways when choosing your AI framework. PyTorch gives you flexibility for research. It is best for innovation, experimentation, and pushing AI boundaries with dynamic computation graphs. TensorFlow shines in scalability and production. With a strong ecosystem, it is the go-to choice for enterprise-grade deployment and large-scale AI applications. Hugging Face is all about accessibility and pre-trained AI. It is perfect for NLP and democratizing AI, making powerful tools available to everyone through its massive model hub. In short, choose PyTorch for research flexibility, TensorFlow for production scalability, and Hugging Face for rapid deployments and easy access. Remember, many teams actually use more than one framework at different stages, so the best choice depends on your project goals.